All right. So the great thing about polynomials is that it's very, very easy to get the functions from their graphs. All right. Because we can always write a polynomial function in their factored form. So remember, the factored form of a polynomial is when you have a set of roots. So that's the zeros or solutions, however you want to say it, or x-intercepts. That's what it is on the graph. It's an x-intercept. Then the polynomial can be written as y equals a times x minus r1 times x minus r2, x, and continue until you get to the last root. Now, a can be determined by another point. So any point on the graph we can use to help us determine a. All right. Now, remember, when you go from root to factor, so this is called a factor, this is called a root. When you go from root to factor, you flip the signs. All right, so for example, if you had x is equal to -2, the factor would be x plus 2. So a way you can remember that is if you set the factor equal to 0, you get the root. Whereas if you try to get 0 on one side of the equation from the root, you get the factor. Because think about it. If I wanted to get this side equal to 0, what would I have to do? Add 2. Don't we end up with x plus 2 equals 0? Yes. So that's the way you can work backwards. So now, let's try exercise 1. So, we're going to determine the equation of a quadratic function where the roots are -3 and 4. So those are my roots, or x-intercepts. And it passes through the point to -50. So remember, a quadratic function. So parent function for a quadratic function is what? What is the parent function for a quadratic? Y equals x squared. All right, so that means that our function is going to have at least a degree of 2. Meaning the highest exponent is going to be a 2. So it will look something like this in standard form. So our end goal is to get the function in standard form, which would be x squared plus something plus another something. Something like that. All right. Now, to get to standard form, we want to get the factored form first, because getting the factored form is a lot easier than getting the standard form straight from the graph or from the roots. All right. So let's first start with getting our factors. So my roots are equal to -3 and 4. So actually, let's not do r. Let's just put x. So that's what my two roots are, -3 and +4. So if we get factors from those two, all right, what is the factor for -3? Can I rewrite -3 as a factor? X plus 3. Good. How can I write 4 as a factor? X minus 4. Good. So my unfinished factored form, and I call it unfinished because we haven't found the a value yet, would be y is equal to a times x plus 3 times x minus 4. So this is the unfinished factored form. Because now we got to solve for a. And solving for a is actually pretty easy. Because all you got to do is, we're going to use this point that they gave us that we know the graph passes through. And we're going to plug it in. So we're going to plug the 2 in for each x. And the -50 in for y. And then we're going to evaluate and solve for a. So in other words, we're changing this into almost a 1 or 2 step equation by putting in actual numbers for these variables. Because remember, a point is just a set of input output. If you put this in, this is what you get out. All right. So that's exactly what I'm going to do. So I have negative 50 is equal to A times 2 plus 3 times 2 minus 4. So what's 2 plus 3? 2 plus 3. 5. So I have A times 5. What's 2 minus 4? Negative 2. Now what's negative 2 times 5? Negative 10. So I have negative 50 is equal to, I'm going to put the negative 10 in front because it doesn't matter with multiplication because it's commutative. I mean, you could switch the values. Negative 10A. And now I got me a nice little one-step equation. So what's the only thing I got to do to solve for A? Divide both sides by negative 10. So my A is equal to what? Not negative 5, but positive 5 because the negatives cancel out. So that's my A value. So now I'm going to take that A value and put it back into my unfinished equation. So my full factored form of this function is y is equal to 5 times x plus 3 times x minus 4. Now, that's factored form. But what did they ask me to put my final answer in? Standard form. All right, now this is review from Math 2 and Math 1. You guys should know already how to convert from factored to standard form. So think about it for just a second. If you saw a problem like this and they asked you to simplify it, what would kind of be your gut instinct to do? Box method or FOIL, distribute of some sort. Okay? So that's exactly what we're going to do. We're just going to box and then distribute the 5. All right? Now, in my opinion, I say do the box method first. So do the x plus 3 times x minus 4 and then distribute the 5. Just because then you're messing with smaller numbers. So we're going to do box method. Now, if you like FOIL better, that's fine. I prefer box, but I don't care how you guys do it. It's whatever you're most comfortable with. All right. So I got my box here. It's 2 by 2 because there's 2 terms in each factor. Put x plus 3 on top, x minus 4 on the side. So what's x times x? X squared. X times 3? 3x. Negative 4 times x? Negative 4x. And negative 4 times 3? Negative 12. Then I just need to combine like terms, which is just the x's, and pull it out of the box. So I get x squared. What's negative 4x plus 3x? Negative 1x, or just negative x, minus 12. And I'm not done because remember, you got to bring that 5 down. So what would be my last step to get this in standard form? Distribute that 5. So my final standard form would be y is equal to 5x squared minus 5x minus 60. So that right there is my standard form. Now, graphing it, really easy. All we're going to do is take the roots and take the point. All right, and then we're also going to use our dance moves. Okay, so first off, I'm just going to graph my x-intercepts just so I know where they're at. So I got an x-intercept at negative 3 and an x-intercept at 4. I'm also going to graph the point that they gave me just so I kind of have a reference point. So that point was at 2, negative 50. So negative 50 will be about halfway down the y-axis. So it'll be right here. Now, if we are looking at the standard form of this function, Is this going to be a even graph or an odd graph? Even. Why? It will be positive. It will be positive. But what makes it even? The highest exponent is 2. But you were correct in that the wheels will be going upwards because it will be a positive graph. Okay. Because our A value is positive. All right. So when your A value is positive, that means it's a positive graph. So that means in behavior wise, how are my tails going to be facing? If it's a positive even graph, they're both going to be going up. So it's a positive even. So that means tails are going up. Now, then I want to look at my factored form for dance moves of how I'm going through this graph. All right, so based off of my 2 factors, what's the only dance move that I'm going to be doing? Across. So, because there's no exponents next to them, so we have to assume that it's 1. So now I got a general idea of what my graph's going to look like. All right, so I'm going to go down. Oops, I hate it when my thing does that. So I'm going to go down, then turn, because it's a quadratic graph, so it should just look like a parabola. Both my tails are going up. All my dance moves are just crosses, no bounces or anything. And it clearly looks like a quadratic graph because it should just be a parabola. We know it's quadratic. No, they already told us it's quadratic. Yeah, they told us up here. So we can just already assume. Plus, when you look at the function, if it has that x squared and there's nothing higher, it's automatically quadratic. Yeah. All right. Now, that looks like a lot of work just to get one equation, but it's honestly not too bad. All right. A lot of these steps are fairly easy. You just got to make sure that you keep organized with the process. The biggest mistake that I see on tests with this is that people will get the factors, but then they don't solve for A. All right. So you got to solve for A. Don't just assume your A value is 1. Sometimes it is 1, but not always. All right. So don't forget to solve for A. All right. Let's try exercise 2. So it's important that we realize the effects of the A value on our polynomial graph. So this is easy to explore when the polynomial is in factored form. So I'm given a quadratic function with this equation. All right. So if I was looking at this, all right, okay, what would my x-intercepts be? So in other words, where are my roots based off of the factors that they gave me? Right. So the way you could have done it is that you could have set both of those factors equal to 0 and solved them separately. So you would get -2 and 5. So these are my x-intercepts, which I'm going to graph here. So I have -2 and +5. Now, here's my question. So this is review from Unit 1. Who remembers what the A value, so the number we're multiplying to a function, controls? What transformation does it control? So whether it stretches or compresses, right? Or in other words, it's dilation. Okay? Does anyone remember the rule for stretch compression? How do we know if it's going to get narrower or wider? So let's kind of just take some predictions here. If we look at these next functions, All right, they're the same x values, but they have different a values. All right, that's the only difference between them. What do you think is going to be the difference between this first function and the second function? So it's going to have the exact same. It's going to have the exact same vertex. It's going to have the exact same x-intercepts. The only difference is one of them has an a value of 2, the other one has an a value of 1. So prediction-wise, what do you think is going to be the difference between the two? So one of them is either going to be wider or narrower than the other. So what do you think? Say it again. So this one, what would it be? Not wider. This one would be narrower. So remember, the rule is that if your a value is greater than 1, your graph gets narrower. If your a value is a fraction, so it's between 0 and 1, it gets wider. All right, and again, that's just review from Unit 1. So if I were to draw a generalized sketch of this graph, here's kind of what the original will look like. And again, it's not perfect. The second graph would be a little bit thinner, but it would still, oops. The second graph would be a little bit thinner, but it'll still go through the same x and y intercepts. And the third graph would be even thinner than the second. And these aren't perfect, all right? But that is how they affect each other. All right? The bigger the B value, the A value, the wider the graph's going to get. Come on, guys, heads up. I know this is dry, but got to get through it. So that A value does matter. Any questions on that? All right. Let's do example 4. Now, the reason I didn't want to do example 3 is that's probably going to be the one I'm going to get you guys to try in a minute because it's similar to the one we just did in example 1. Example 4 is a little bit different though. Not much, but there's some different vocabulary that we just need to talk about. All right. So they want us to create an equation of a cubic function in standard form that has a double 0 at -2 and another 0 at 4. They then said the y-intercept of the function is 16. First off, what in the wide world of sports do you think double 0 means? What? Think dance move. What do you think a double 0 would mean as a dance move? What dance move do you think? Think of what the word double means. It means 2. So think about it. What dance move do you think that would correlate with? I'm sorry, what you asked? So which dance move do you think, if double means 2, which dance move do you think that would correlate with? A cross, a bounce, or a wiggle? A bounce. All right. So all a double 0 means is that we count it twice. So technically, our factors are x equals -2, -2, and 4. So we have to count -2 twice, meaning we're going to have to write the factor twice. Because what's going to happen is that our dance move will be a bounce when we graph it. So this becomes a bounce when you graph it. So let's get my factors first. So y equals a. What is -2 as a factor? X plus 2, good. So I'm going to write that twice because I have to count it twice. What about 4? What's that as a factor? X minus 4. Now, before we go any further, could I rewrite this part right here? Yes, how?
Do x plus 2 and x plus 2.
Yeah, you can do x plus 2 squared because we're multiplying something by itself. All right, so I'm going to rewrite this using the square. So a is equal to x plus 2 squared, x minus 4. So we said that double zero is going to bounce. Based off the exponent that's with it, will it bounce? Yeah, it will. Because it has that 2 in the exponent. All right. Now, that's our unfinished factored form. Because now we got to solve for a. So they didn't actually give me a written out point. But what piece of information did they say that I could use? The y-intercept is 16. Because technically the y-intercept is a what? It's a point on a graph. All right, so that's actually our point that we're going to plug in. So how would I rewrite y-intercept is 16 as a point? What would that point be if the y-intercept is 16? 0, 16. So this is the point that we're going to plug in for x and y in our function. So I'm going to have 16 is equal to a times 0 plus 2 squared times 0 minus 4. So what is 0 plus 2? 2. So I have 16 is equal to a times 2 squared. What's 0 minus 4? Negative 4. What's 2 squared? 4. So I have 16 is equal to a times 4 times negative 4. And what's 4 times negative 4? Negative 16. So I have 16 is equal to negative 16a. So what do I need to do to solve for a? Divide by negative 16. So what's a equal to? Negative 1. So my a value is negative 1. So now I'm going to take that, plug it back in to the a value of my unfinished function. So my final factored form is y is equal to negative. You can put negative 1. I'm just going to leave it as a negative because technically you don't have to put the 1. You can if you want to. Negative times x plus 2 squared times x minus 4. So that's my factored form. Now, standard form. We got to do some stuff to get to the standard form. So when we do box method, remember, x plus 2 squared is the same thing as this, x plus 2 times x plus 2. So you still got to do a box method with it. It's not going to be, x plus 2 squared is not x squared plus 4. It's going to have an x value in the middle of those two terms. All right. So the easiest way to get the standard form, my recommendation, do 2 box methods. All right. So do it with 2 of the factors first. Then take the third factor and the answer you just got from the previous box and do a box with that. All right. So just for my sanity, I'm just going to rewrite it with the expanded x plus 2 squared. All right. Just so I remember to include the x plus 2 in my box method. So I'm going to do my first box, and I'm just going to use these 2 terms. So I'm going to do x plus 2, x plus 2. What's x times x? X squared. What is 2 times x? 2x. This is still 2x. 2 times 2? 4. Combine like terms and pull it out. I get x squared plus 4x plus 4. Then I'm going to bring down my other factor as well as the negative in front of it so I don't forget about it. Now I'm going to do another box method using the answer I just got and the other factor. So now when you start dealing with trinomials, I recommend doing box method over FOIL just because you can FOIL, it just gets dicey the more terms you add. All right. So box method just keeps it a bit more even or organized, I should say. So I have x squared plus 4x plus 4, and then x minus 4 on the side. What's x squared times x? X cubed. What's 4x times x? 4x squared. What's 4 times x? 4x. What's negative 4 times x squared? Negative 4x squared. What is negative 4 times 4x? Negative 16x. What's negative 4 times 4? Negative 16. Then I pull it out and combine like terms. So my like terms are my x squareds and my x's. What happens to my x squareds? So if I add negative 4x squared and 4x squared, what happens to them? They cancel out. So I don't even have to include them. All right. So I have x cubed. What's negative 16x plus 4? Minus 12x minus 16. And what am I missing? The negative in front. So I'm going to put this in parentheses, bring the negative down. So what's my last step to get it in standard form? Distribute that negative, which is just a fancy way of saying just switch all the signs of the terms. Say one more time? Yes. Just let me, here, I'll zoom out a little bit. Does that help? So I distribute that negative. So my final standard form is y is equal to negative x cubed plus 12x plus 16. Now, let's go ahead and graph it. So first off, let's just use what we know to determine what we're going to graph. So first off, I'm just going to go ahead and graph my points. So I got negative 2 as an x-intercept and 4 as an x-intercept. And then my y-intercept is going to be about right here at 16. Now, based off of my standard form, is this going to be a positive or negative graph? Negative. Is it going to be odd or even? Odd. Because my highest exponent is 3. 3 is an odd number. So what's my tails going to look like? Am I going to start high and get low or start low and get high? Am I right? Yes. Where'd Hayden go? All right, so are the tails going to start high and get low, or are they going to start low and get high? So in other words, is the left tail going to be up or down? It'll start up. So here's how you can think about it, guys. Think about it as a linear function. Positive functions increase, so it starts low and gets high. Negative functions decrease, so it starts high and gets low. That's how you can remember it. All right? So just think about if you drew a decreasing line, hey, they need you at the office. Or if you start, so just remember, a decreasing line always starts high and gets low. If you go from left to right, yes, yes. Whereas increasing starts low and then it gets high because it's going up. That's the way you can remember it. Just think about it as a straight line. So And then what's going to happen at x equals -2? What dance is going to happen? So based off of my factored form, amount is going to happen at -2. What's going to happen at 4? Across. All right. So my graph's going to look something like this. So I'm going to start up high. When I get to -2, I'm going to bounce, go through this point, and I'm going to cross at 4, and then my tail's going to remain going down. So that's kind of a general idea of what my graph's going to look like if I graph that in Desmos. Does everyone understand what I'm doing here? Okay, so take a minute. I'm going to leave this up, but try exercise 3 on your own. Yeah. Name on the board? Yeah, go ahead. So I'm going to leave this up just for an example. But I want you to try exercise 3.
It here because
That's
I like I'm sorry.
You're okay. It's your notes. You're fine. I don't think I'm packing your notes. So you're going to try exercise 3. You just did exercise 4, so we're trying 3. Come on, guys. Try this problem. Get to work. Yeah, so you're finding factors first. Then you're going to use those factors. Once you get that, box no. You plug it in as I just need to start boxing. You just slide off. Yeah, for 1/2. Either way. It can happen. So you got the chapters. Now you're going to use this point, plug it in the X So the box is just divide by degrees. You just have to, this is not correct, you just have to, you have to multiply your scale. So you just divide out by 1/2. Hey, so, it's an accessory. Just take it and write it. Or you can write it down. Stop taking my history. Cut it out. Cover your paper. Cut. Take your paper out. I can't. It's such a personal thing. Okay, so here's again. So here's okay, so that okay. And whatever you do with that, okay, so we're gonna also now I don't know that. Yeah. Give it to me. All right, guys, I'm gonna give you about 2 or 3 more minutes. We are close. All right, let's come back together. It's amazing that you guys know what I said at all, because you won't stop talking. I said I was ready to come back together. That means shut up. All right, so I'm going to call on people to walk me through the steps. So let's go with finishing your test. Finishing your test. Michael. So how would I rewrite my 3 roots as factors? So x, okay, shh, x minus 2, good. All right, so there's my unfinished factored form. Michael, pick on someone to do the next step for me. Which one? Okay. Jonathan, what do I do next?
Use the point 620.
Uh-huh. Right.
So it'd be 24 6 plus 4, 6 minus 4, 6 minus 5.
Good. All right, call on someone to keep going. Say it one more time. Good. So 10 times 4 times 1. Which, Shaki, what's 10 times 4 times 1? 40. So I get 20 is equal to 40a. So, Shaki, pick someone next. All right, JJ, what do you do next? Okay, so what's a equal to? 0.5. I'm going to say 1/2. All right, if you put 0.5, that's fine as well. All right, so if I rewrite it, I have y is equal to 1/2 times x plus 4 times x minus 2 times x minus 5. So that's my factored form. So, JJ, pick someone to help me with the first step of getting to standard. Oops, 5. right, Chase, what's my first step to get to standard form for my factored form?
Box.
Box what? So remember what I said, you just pick 2, and then whatever you get for that, then multiply the other one to it. So which 2 do you want to do? All right, so let's do x plus 4, x minus 2. So I have x plus 4, x minus 2. So fill in the box for me, Chase. Okay. Good. So if I pull everything out and combine like terms, I get y is equal to 1/2, because I still need to bring that down, x squared plus 2x minus 8, and I still got to do x minus 5. So I'm going to continue over here. Chase, pick someone to do next. All right, Dylan, what's my next step? So I did one box, so now I got to do another box. All right, so I'm going to do a 3 by 2. So x minus 5 is on the side, x squared plus 2x minus 8. Dylan, fill in the box.
X cubed. 2x squared. Negative 8x. Negative 5x squared. 10x.
Good. So if I combine like terms and pull it out, I get x cubed. Negative 5x squared plus 2x is negative 3x squared. Negative 10, negative 8, that's negative 18x plus 40. But I still got to make sure you have that 1/2. Dylan, pick someone to do my last step. Just put it on my desk. So who was it? All right, David, what's my last step? Distribute the 1/2. Good. So I'm going to distribute the 1/2 to every term. So David, what's my final answer? Minus 1.5 or 3/2 x squared. Minus 9x, and then good. So here's my function in standard form. Now we're at the graphing aspect. So I'm going to graph everything that they gave me. So I have my 3 zeros. And then I have a point at 620. So 20 would be about right here. So, David, pick someone and tell me what my graph's going to look like. Okay, Dominic, first off, if I look at my standard form, is this going to be an even or odd graph? It's going to be odd, and it's going to be positive. So what's the tails going to look like? Right, left down, right up. Okay. What's my dance moves going to look like? So look at the original factored form. It just crosses for all of them. All right. So I'm going to start low. So I have here. And I'm going to go here, curve back around, and go through my points. So your graph's going to look like that, or something like that. It's not perfect. We're just sketching it based off of what we do know. Okay, any questions on any of this? All right, so that's it for today. Your assignment for today, there's a Delta Math for 3.1, 3.2. All right, don't forget you also have that 3.1 quizzes. All right, so I expect you to be working. And by the way, guys, I know math is not the most invigorating topic, but you gotta try. You're not just gonna sit there while I ask you guys to do a problem and do nothing. If you have issues, just ask me, please. Because I can tell you right now, the more you practice it, the better you'll be. All right, because if you don't practice it, it's not going to be pretty. And your test scores from the last test showed that.